Hi everyone, and welcome to the lesson Nested Structures. Now in this lesson we're going to be looking at sort of a better approach to organization by using nested structures. So as we saw in our previous lesson on creating structures, where everything was, I say loose, but there were lots of variables in one structure. This is tidying that up into lots of different structures, but referencing those from a common structure, and it'll make a bit more sense as we sort of dive into it. So on my left hand side here you can see that I have four structures now, one called analog, one called AnalogStatus, ScalingData, and pressure. So if we have a look at pressure, this contains most, if not all, of the same information that we had in our previous lesson, but it looks very different. So now we have a raw, scaled, and analog. And analog is of type DUT analog, which we have here. So essentially what I have here is a structure with another structure inside. So if I go and have a look at analog, I can see that in analog I have raw and scaled. Now the reason why this appears in both is it's a personal preference of mine, which is anything that is going to be commonly used, such as the raw and scaled value. I'm going to want to be able to access that information without having to keep diving into substructures. So what I do in my sort of function blocks that manage these instruments is I kick that up to the topmost structure, so it's nice and easy for me to access it without having to sort of deep dive into structures to get that information out. So I have raw and scaled in my analog as well. That will become more apparent later on. Why sort of an example of why we do that. And then I have my scaling data, which again is another structure type, and my status, which is another structure type. So I have my my scaling data here, which is my raw min, raw max, scale min, scale max. And people sort of say, well, it's only 4 elements, why is that in a structure? But it makes it very, very easy to just pass to a custom-made scaling block. I know that all of the information in there will be correct, and then later on, when it comes to modifying that data on SCADA or on a HMI, I can have a faceplate that accepts only this data type, which again means that that information has to be there and it has to be correct. I'm not going to be able to pass it an incorrect data type. So it just enforces that if somebody goes and makes a new instrument or a new function block, a new instrument, and doesn't include a method for scaling that information, you're not going to be able to pass any information to a HMI or SCADA system where we need to interact with that data. So again, going into analog status, in here I now have out of range high, out of range low, and a general out of range, and also a diagnostics out of range time, which would capture the time of day that this happened, which just helps a PLC engineer come in and have a look at when did this first occur, and also can be passed to, again, faceplates that interact with this status for diagnostic screens. You've got to imagine that this might be much bigger with many more statuses in and more diagnostic sort of elements to it. This is just an example. So if I come into my my analog again, my pressure again, everything that we've just seen in terms of all of that information is all accessible from this DUT pressure, as long as there's an instance of it. So let's go ahead and create a instance. So I'll just leave that as GVL, and in here I'll create my pressure 1, and it's of type DUT pressure. And then if I go to my PLC program and I create a instruction and I do GVL dot pressure 1. So what you can see now is obviously I can't access raw or scaled because they're not Boolean data types. But I can go into, well, I can access them, but it won't compile. But I can go into AnalogStatus and here's my information on whether I'm out of range, high or low. And I can go on and use that information as if it was just a loose tag that we looked at back in the introduction. This is the only drawback that I find in Codesys with structures, and that's the fact that the name gets very long, or can get very long, if we do sort of more nesting, or if our names are a bit more lengthy because we want to be clearer on what these tags are. You can get very long names. But apart from that, this is the best way of structuring your data. So again, if I drop in a if I drop in a move command and I go into GVL dot pressure 1 dot scaled dot analog dot scaled scaling data even. What I can do is move entire structures. So I'm not accessing just an element here. I'm accessing an entire structure. So if I was to go into GVL and create a pressure 2, and then back in here, I could actually move that information into pressure 2. So for example, we have a common scaling profile for all pressure transducers, except for maybe 3 or 4 out of 20. We may opt for having a standard scaling data structure, which is moved into every single one that uses that standard approach, and then the ones that don't use that approach are just interacted with normally on SCADA or the HMI. But that's showing that we can move entire structures as long as they are of the same type. And again, going inside, I can move raw max, for example, and access raw min, scale max. So you can still access structured, nested structured data in exactly the same way as normal structured data.